Well, that gives me a perfect segue, considering more paper folding. So I'm going to talk about paper folding to the moon. I have to be honest with you, it's not my idea, right? To those of you who know me, I am big on procrastinating, and as a result of procrastination, I came across this TED talk by Adrian Pienza, and he was talking about paper folding and how, I'll go through it here, right? So what I want you to get out of this is what I did with this particular TED Ed talk. Instead of just taking what I've got, take the idea away from it and then turn it into something that will work with your class. Okay, scaffold it however you want, structure it however you want, something that your kids are going to really get into. I had one goal for my students, and that is to move them away from getting just the answer. I hate it when kids tell me, just give me the answer, tell me how to do it, right? Want them to think critically, I want them to work together, and I want them to come up with creative ways of getting to the solution to the problem that I'm about to pose. And the most important thing is to get them to communicate. And that is not just verbally communicating to each other, but writing things down on the page, mathematically, and using words. And I'm finding that lots of kids are afraid to use words in maths to explain themselves. And I'm always trying to get them to use words more often. So here's some preamble for the problem. Suppose that you can fold a piece of paper many, many times over and over again, and you'll get the smart kids in the class and go, "Oh, sir, but Mythbusters have proven this, otherwise." Just ignore them. And suppose you have a piece of paper of infinite size. So basically, when you fold it over and over again, the piece of paper doesn't get smaller. The question is, how many folds would it take for you to create something that's thick enough to reach the moon? So I started with getting them to do a bit of estimation. Okay, and it's surprising to hear what the kids have to say about it. Lots of kids went for 100 folds or more because they haven't really studied exponential growth, right? So obvious things to do is looking at thickness of paper and stuff like that. I won't go through the concepts, but you can really study, the concepts of maths, talking about measuring devices, limit of reading, error in measurement, and so on and so on. I'm sure that presentations will be made available to you through Judy, and other things like that. You can talk about significant figures, looking at units, measurements for very large units, and stuff like that. And it has a very nice solution, which is why I really like the problem. Look, I didn't go through the slides in detail, but when you get a chance, go through the slides. The maths is there and the calculation is there.